Hello algebra students, this is 8.4 add, subtract, and multiply radical expressions, part 2. Let us remember that a plus b squared is a perfect square trinomial, a squared plus 2ab plus b squared. And then remember that a minus b squared is a difference of squares, so that factors to, oh no, I'm sorry, it's not. It's also perfect square trinomial, and it factors, or it multiplies out to be a squared minus 2ab plus b squared. The next one is a difference of squares. So these are perfect square trinomials. And this one is a difference of squares, so it foils out to be a squared minus b squared. Difference of squares. Okay, so we can use that special factors to help us multiply and simplify. So here we get, so what we're doing is we're going to take the 3 and we're going to square it, and we're going to double this, and we're going to square the last term. Okay, 3 squared is 9, plus 2 times 3 is 6, square roots of 5, plus the square root of 5 squared is 5. This simplifies to just 14, plus 6 square roots of 5. On this next one, we're going to use the same process. It's a perfect square trinomial. So we're going to square the first term, minus, we're going to double and then the last term is squared, and since it's squared it becomes positive, so 5 square roots of 7 squared. Alright, so that is, let me just color code it. We have a squared, that's a. We have 2 times a times b and then we had b squared. When we square the first one, we get 2 squared is 4, the square root of 3 squared is 3, minus 2 times 2 is 4 times 5 is 20, square root of 3 times the square root of 7 is 21, plus 5 squared is 25, the square root of 7 squared is just 7. Alright, and now we just simplify. 4 times 3 is 12, minus 20 square roots of 21, and 25 times 7 is $1.75. We can add 12 and 75, so that is 187 minus 20 square roots of 21. Let's take a look at example C. We're going to square the first term, so that's 3 squared. We're going to double and then write each term. And then we're going to square the last term. All right, 3 squared is 9. This is going to become 6 square roots of x minus 9, plus, when this squares, it cancels the square root, so it's x minus 9. All right, notice how there is a positive 9 and a negative 9. Those cancel, leaving us with just x plus 6 square roots of x minus 9. So this is just special cases. In our class before this, we FOILed out already. We already FOILed radicals. This is just special cases. So if you want to, you can always revert back to FOILing. A little bit about conjugates. Given b and d is greater than or equal to 0, if we have a square root of b plus c square root of d and a square root of b minus c square root of d, those are conjugates of each other. They're kind of like opposites. So this one is the positive version, and this one is the negative version, and those are called conjugates. Let's see what happens. When we multiply conjugates, it looks like a difference of squares, and it is. So this becomes 6 times 6 is 36, minus the square root of 11 squared, which is just 11, and that equals 25. Let me show you how I got that. So I just did a difference of squares. So 6 squared plus, minus the square root of 11 squared. And when you square those, the square root goes away. All right. I'd like you to try B and C in your groups, so I'm going to pause the video, and you can ask any questions that you have. Check your answers, see if your group was right. And then let's look at D. We have variables in this problem. So we're going to take the square root of 2x and square it. Subtract the square root of y squared. And that simplifies to just 2x minus y. As an irrational expression, it is customary to rewrite the fraction with a rational number in the denominator. And this is called rationalizing the denominator. This often involves multiplying the fraction by a clever form of 1. When you're ready, turn the page. So we're starting section 8.5 by rewriting with a rational denominator. That's how part 8.5 starts. So we have here a square root 7 in the bottom. Now if you multiply by the square root of 7 over the square root of 7, that is actually multiplying by 1. That becomes the square root of 35 in the numerator, and the square root of 7 times the square root of 7 is just 7. I'm going to pause the video, and I want you to work on B and C at the whiteboards in your groups. And check your answers, see if you got the same thing in your groups, and you can write them in your notes. Now we're looking at D. D has a cube root. And so we need to multiply by something that will get rid of that cube root in the denominator. And so if we multiply by another cube root of 2 and another cube root of 2, that means that we would have 3 of those, and then it would come out. So 2 times 2 times 2 is 8, and so we could take the cube root of 8. Right, so now we have 3 that we're multiplying by. So in the numerator, that's going to be 3 cube roots of 4, and in the denominator, it's going to be 3 cube roots of 2 times 2 times 2, which is 8, which then simplifies to 3 cube roots of 4, and the cube root of 8 is 2. Notice how we no longer have a radical in the denominator. We will sometimes have to use conjugates to rationalize the denominator. Did you notice on the page before the conjugates, they ended up becoming whole numbers? So looking at example A, what is the conjugate of 5 minus 2 root 7? It's going to be the positive of that. So we'll multiply the numerator and the denominator by the same. 5 plus 2 square roots of 7. That will give us, and we'll distribute here, 3 times 5 is 15, plus 3 times 2 is 6. Sorry about the door keeping opening. And then we have 5 times 5 is 25, minus 2 times 2 is 4, and the square root of 7 times the square root of 7 is 7. Now we'll just simplify that. Showing our work, 15 plus 6 square roots of 7, and that's going to be 25 minus 28. 25 minus 28 is negative 3. Oh, now I wanted to cancel the 6 or the 15 with the 3, but I cannot, but I can if I factor out a 3. So factoring out a 3, I get 5 plus 2 square roots of 7 over negative 3. The 3's cancel, so that equals negative 5 plus 2 square roots of 7. Can you do B and C in your groups at the board, and I'll be coming around to help. Now check your work, make sure that you got those correct, and set up your homework paper.